Welcome to In 5 Minutes. The agenda of this clip is to understand clock stabilization. Ideally, in the previous clip we have seen how clock is generated internally from an external reference clock. Now we know that the clock which is generated internally needs to be synchronized with the external clock. Then only my operations which we had pre-decided will happen correctly. In order to attain this synchronization between an external clock and internal clock which is generated for the internal circuitry, we need a technique which is nothing but stabilizing the clock or clock stabilization. Let's understand the basics of clock stabilization and then we'll go into the details of how exactly this happens. Don't get intimidated by what you see on the screen. It's a very straightforward block diagram where I have an external clock which is present here. The external clock is given to my clock generator circuit. We saw previously in the previous clip, this was my external clock and we passed it through a scale of or through a chain of inverters or through a latch. We have already done this in the previous clip, right? And here was our capacitor and we generated phi and phi bar internally for internal operation. So the same thing, my external clock is given to my clock generator circuit that produces the necessary phi and phi bar. Now this in turn is given to a voltage controlled delay line unit. We'll understand what does this do. This is a delay line which is controlled by a voltage from a low pass filter. We'll understand quickly what is going to happen. Delay line itself suggests that it will slow down my signal in case the need be. We will see when that happens. So external clock given to a clock generator generating phi and phi bar. It's given to a delay line which is controlled by a voltage from a low pass filter. Depending on the voltage, it will slow the signals if the need be. These signals which are slowed down are given to a chain of buffers or a chain of inverters which will work as a buffer in order to restore my signal strength. And finally then it goes to the blocks or to my IC which has all the different points which needs to be driven by clock. Now the same clock which is going to go to different points is on the feedback path and it's going to go to a phase detector with its other input nothing but an external clock. This phase detector is nothing but a comparator and we can use an XOR gate also as a phase detector. What this phase detector is going to compare is whether my inbuilt clock or whether my generated clock internally is in the same phase with the external clock. So suppose this is my external clock. We want our internal clock also to be the same. But for some reason, if this deviation of the phase happens, then the phase detector or a comparator will compare this difference in phase and it will produce an output that indicates if my output signal is leading or lagging the external clock. So basically the output of this comparator or the phase detector is going to tell us whether my internally generated clock is leading or lagging my external clock. This output voltage will be given to a low pass filter and it produces a voltage that will adjust the delay line. For example, if this was like this, where this was my external clock and this was my internal clock, the phase comparator or the phase detector will detect this small difference. It will produce an output which goes to a low pass filter, which in turn will produce a voltage which will ensure that this will get synchronized to the external clock. Very simple. This is nothing but the concept used by phase lock loops. We'll understand the details of phase lock loop in a minute or in a few seconds. What you need to understand from this general block diagram here is that you have an external clock which is passed to a clock generator circuit which generates your phi and phi bar, which will go through a delay line which will be controlled by a voltage of a low pass filter and pass through a chain of buffers. Now how do we ensure that both of them are in the same phase, or how do we ensure that our frequency is stabilized or our clock is stabilized? We connect our output voltage or we connect our output clock and give it to a phase detector along with an external clock. The difference in the phase would be detected and the output is given to a low pass filter which will produce a corresponding voltage and will be given to a delay line which is a voltage controlled delay line. Correct? Very simple. This is nothing but the concept of PLL. You will understand this